Okay, so we reach the third part of chapter 6, which is how do I find exact values of angles with respect to their sine, cosine, and tan. And those values are 30, 60, and 45 degree. In the first part, we learned how do I find the sine, cosine, and tan for angles as 0, 90, 180, 270, and 360. And I find those values from the unit circle. Now, I need to have another way to find the values for 30, 60, and 45. To start with the 30 and 60 angle, if I have an equilateral triangle, we know that an equilateral triangle have 3 equal sides and 3 equal angles. If this equilateral triangle has a measure of 2 as the length of the sides, and let's say the angle definitely are 60 degrees, if I drop the altitude in this right triangle, equilateral triangle, it will be at the same time median, which means bisect the opposite side, and it will be at the same time angle bisector. So let's take 1/2 of this triangle. I will be getting this triangle, this right triangle, which will have this side is 1, the hypotenuse, which is the length of the side of this equilateral triangle, which is 2, and the third side of this triangle, I will get it using Pythagorean theorem, which is 2 squared minus 1 squared, which is a square root of 3. As for the angles, I have this is a 90 degree angle, this is 60 degree, and this one on the top is 30 degree. Now let's apply the sine, cosine, and tan ratio in order to find all those ratios for the 30 and 60 degree angle. So this is the triangle that I find earlier. This is 60, this is 30, this is radical 3, 2, and 1. Now, what is sine 30? It's the opposite, which is 1, over the hypotenuse, which is 2. Cosine 30, it's the adjacent, which is radical 3, over the hypotenuse, which is 2. Tan 30, which is sine 30 over cosine 30, which is half over radical 3 over 2, so I get it 1 over radical 3. I should rationalize the denominator, so I get that tan 30 is radical 3 over 3. Similarly, I find that sine 60 is radical 3 over 2, which is opposite over the hypotenuse, cosine 60, which is half, and tan 60, which is sine 60 over cosine 60, and I get it to be radical 3. So, in order not to memorize the ratios for angle 30 and 60, I can simply use this semi-equilateral triangle. I call it semi-equilateral triangle. I can find the ratios accordingly. One special triangle is called the isosceles right triangle. The isosceles right triangle, it's a right triangle, and since base angle of an isosceles triangle are equal, so I will be left with 45 degrees for each of the acute angle in this right triangle, and I have equal legs. If this side is 1, then definitely the second will be 1, and so the hypotenuse by Pythagorean will be square root of 2. Then sine 45 in this case will be equal to cosine 45, which will be equal to radical 2 over 2 after rationalizing the denominator. And tan 45 will be equal to 1, since sine and cosine have exactly the same value, so when you divide them you get 1. So there, those ratios, the 30-60 ratio and the 45, we should find them, or we should know them in case they ask us as a question, find the exact value without using the calculator. One of those questions will be this one. Find the exact value of sine minus 2tan. Again, before I start, I need to just sketch quickly the coordinate plane. Minus 210, it means you have to go clockwise because the negative direction, it's from the x-axis clockwise. And I'll go all the way through this quadrant. So this angle is minus 210. If up to here it's 180, so what is left for this acute angle? 30 degree. So the angle that I got is in the second quadrant. And from the cast diagram, I know that the sign in the second quadrant is always positive, which means sine minus 210 with respect to its acute value will be equal to sine 30, which in this case is equal to half as a positive value. You can try out to find the exact value with respect to 30, 45, and 60 degree of all these angles, to find in which quadrant they are located and to find whether their sine, cosine, and tan is positive or negative in the quadrant, and to refer them back to 30, 60, and 90 degree as we did in the example earlier, and you should be getting these answers. So try them out and hopefully you understood everything. Okay. So in the next video will be our last part of chapter 6, which is solving trigonometric equation.